essentially. So to talk, let's go back to one of the papers of DeepMind. So this is about the complexity of 3D simulations, especially many body physics simulations, where you have a lot of like simulators out there for rigid body dynamics, where like you induce friction, induce damping, and you can kind of like predict what's the motion and like the joint movements in the robotics would be like. But one of the most difficult problems is when it goes to soft matter physics and amorphous liquids or gases. So there was an interesting paper a few years back by DeepMind where they use graph neural networks to basically predict the next states of the body, like the evolution of this liquid going back and forth. And the results were very interesting. I can, because I've been like going back and forth, let me just show you. So this is like the decomposition of that. So you can see in this, so you have a basic architecture of encoder, processor, and then a decoder where you load in the data of the starting states of that complex system, and then it helps in predicting in the next states. So you see the particle render of the ground truth, which is like numerical approximations, and the predictions are not that far off. So it's basically creating a very accurate render of a real physical system, which is extremely important. So going back to the diagram, so hold on a second. Yeah, so it's like a very simple architecture, graph neural networks that they've used to basically map every particle and the movements that it's going to achieve in the time frame onto each node, and then it passes messages and basically extract the dynamics info. So the reason why I'm here, I'm trying to recreate this with an AI native physics simulator. And although it's like a very complex problem to like have a universal physics simulator, I am approaching it in the sense of like making intuitive interfaces where people can define any type of complexity, any type of parameterization, the bodies that they want to like simulate, and have any kind of like interactions with. So it would be really easy to prototype, it would be really easy to conduct experiments, and just like would increase more science and more work across the industry. So it's this is the overall demo of like what it will look like. You can just basically like simulate robots, optimizations, all wormholes, and so it's just like, it's basically text to parameterization of different constraints of that physical system, and it can just, you know, you see this as like a wave displacements across like many body physics. This is just pretty simpler to get, but it's for the intuitive interface sense. So yeah, that was the gist of the talk, and if you guys have any questions.